Hey everybody. So I want to do a little exercise here where we take a graph that's given and try to find a function whose graph this is. And what we're going to find, well, there's a few things. One of the main points of this is that it's not going to be unique, meaning there's more than one way I can write down this function, but we'll come to that towards the end. I also want to talk about why this is important. For one, it's just as a good exercise forcing us to dig apart those pieces of the sinusoidal functions that we've been talking about a bit. Two, it's also something that we might do as a scientist, where instead of given a graph like this, we might have a set of data. And we're doing a very similar process to find then a function that expresses the shape of that data. So that's what we're working at here. So let's just go ahead and dig in. And let's start by, let's talk about what kind of function we're going to find. So remember, sinusoidal functions come, whoops, let's make this a bit smaller, come in, for our purposes, two styles. So let's draw. And maybe this. We've got y equals a sine b bx minus c plus d, and y equals a cosine bx minus c plus d. Okay. So let's just jump right in. I'm going to try to find a function of the second type that matches this graph. It turns out I could find a function of either type. Looking at this graph, right? Remember, sine and cosine really are the same shape, just shifted. Right? We've seen this already, and either these will work to come up with this graph. So I'm just going to choose the second one. Okay. That choice is fairly arbitrary. If I'm asking you to do one of these, I'll probably tell you which one I want you to choose, but in the real world, you can choose whichever one, unless there's some reason somebody wants one or the other. We might just choose one pretty arbitrarily. And there's actually a few choices we're going to make along the way that you have options on, and you can choose what makes things easiest. So let's do a few things. Let's start by computing. There's a few values that are pretty straightforward to get. So let's just start going through. Let's start with A, which is the amplitude. And the way we talked about the amplitude was the distance from the midline to a max or a min. Right, so if we have a graph and a sinusoidal graph and it's got a midline, right, we'll have something that looks like this, and the amplitude was this distance here. An alternative way to think about the amplitude, we could look at the total distance between a max and a min and cut it in half, right? And that might be a bit easier in this case. So if I go to my graph here, and if we're working on paper, hopefully some points are labeled. I have the advantage that I can click on some points, supposedly make them stay. There we go. So now I have 2 points here that I have a peak, and all I care about right now is the output value. The peak is at 4, and the minimum is at -2, right? So I want to know the total distance between these two, or half of the total distance, and that will give me my A value. So let's just go ahead and do that. So that means A, well, what's the distance between the max and the min? Well, when you want to find the distance between two numbers, you take the big number and subtract the little number, right? If they were 5 and 3, the distance between them is 5 minus 3 or 2. You could also say it's the absolute value of their difference and not worry about which one's bigger. But when we're looking at these, it's going to be pretty easy to, right, the max is going to be the bigger one. And then we want half of this. So we'll have half, the max is 4, minus the min, -2, is 1/2 of 6, or 3. So I've got my A value, okay? Now here's one of the places where we're making a choice. Technically speaking, the amplitude is the absolute value of the A value, so -3 would also be a valid choice for A. I find that throwing a negative on here makes it more complicated. There are times when I do it for various reasons, but if I don't have to, I just keep the A positive, okay? All right, remember what that does, it flips the graph. And what that essentially will do is if I made this negative, then I would have a different choice for my phase shift, and we'll see that a little later. But right now I've got my A value. I can also get my D value pretty easily. Remember, D is the midline. Okay, so let's look at this picture again that I have here. The midline is halfway between the max and the min. In other words, it's the average of the max and the min. And so this is pretty easy. How do you get the average of two numbers? You add them together and divide by 2. So now I've got 1/2 of 4 plus -2. 4 plus -2 is 2. Half of that is 1. So right away, I've got my my midline and my amplitude. So I've got 2 of the 4 values taken care of. All right, let's go to the period. That's another relatively straightforward one to get from the graph. So I just need to find any period where it goes through a full cycle, right? So that could be starting somewhere in the middle, going up, back to the middle, down to the bottom, back to the middle, or I could start at a peak and go to the next peak. Let's look at that. So if I look at this peak, get rid of this. If I look at this peak and this peak, we're at pi over 2, 4. We go all the way down and back up to where we started, to 3 pi over 2. That took us a distance of pi, right? There's pi. So our period is equal to pi. But let's notice, had we chosen to look at 2 different points, right? Here is at the bottom, pi over 2, 0 to pi again to get to the same bottom, right? Or if we pick something here, it's less obvious because it's in decimals instead of nice whole numbers. But the difference between these two x values, 0.615 and 3.7517, should turn out to be pi. There's some rounding happening there, okay? So it doesn't matter. And also notice we have to be careful if we don't pick a minimum or a maximum. When I pick, let's clear some of this. If I pick this point here, I might think, oh, if I go all the way up and back down, I'm back to where I started, but I'm not really back to where I started because at this first point, this is where my output is 0 and I'm moving up, but here I'm at 0 and moving down. It's not until we get over here that we're back to 0 and moving up, right? So we have to make sure we get a full period. So I usually just pick 2 maximums or 2 minimums in a row to get my period from the picture, right? And so we see that the distance between these 2 maximums is pi, so our period is pi. Then we have to remember that, and actually let me clean up a little bit before I do this. I'm just going to rewrite on this side what these values are and then box them because I'm going to want to find all these in just a minute. So there's my A value, there's my D value. So I have the period, and we just need to remember that the period is related to B, but it's not the direct relationship we have here. The period is equal to 2 pi over B, right? Well, now that I know what the period is, this equation becomes fairly simple. Pi is equal to 2 pi over B. You can solve this pretty easily to get B is equal to 2. Okay, so now I have my B value. Okay, so what we have right now is a graph of, well, let's write in what we have. Sorry, we don't really have anything. So without the phase shift, so far I have, we've got our amplitude is 3, cosine of 2x, I'm going to leave space for the phase shift, plus 1. Okay. So let's think about what this graph might look like. I'm going to do a sketch on top of all this other pictures. So I'll put in my midline. It's not perfect. We're going to erase all this in a minute. I know that my graph, its amplitude is 3, so going up from 1, it'll go as high as 4 and as low as 2. And if I was, and the period is pi, so I should do a full period by the time I get out to pi. Well, if this is all I wrote, cosine starts out at its maximum and will do a full period by the time it gets to pi, so that means it must hit its minimum halfway through. We would have a graph like this, right? I'm only drawing one period. You can repeat that. But obviously, the graph that I'm looking at here is shifted. And so I'm just going to take this peak right here and imagine that I want to move it to this point over here. And that will shift the whole graph over. Notice I could choose something else. I could choose to move it backwards, and that shift would also work. Here's another place where we have shifts. I could choose to move it all the way up here for some reason, shift it by more than a full cycle. Right? So I have all those kind of choices. Another choice I have here is if I just flipped my graph upside down, this would also match what we have. And I could do that by putting the negative in front of the a. I chose to keep a positive when we began. I didn't know it would do this, but that would also be a valid choice here, is making a negative. But I'm going to choose to put the phase shift in. And sometimes as you progress in your scientific career, these phase shifts might have meaning, and then there's less choices, right? So what we really want to accomplish right now is being comfortable with all these pieces. And we can use the ones that make sense for the piece of the universe we're trying to describe. So let's look at our phase shift. If I'm talking about moving this point from 0, I want that now to happen at pi over 2. So I'm sliding the graph over pi over 2 in the positive direction. So my phase shift is pi over 2. But remember, the phase shift is also equal to c over b. So that means I have pi over 2 is equal to c over b. B is 2. This is very easy to solve and see that c is equal to pi. And so there's the last piece of my puzzle. And let's put in minus pi there. Remember, we're subtracting c. So even though c is positive, we're subtracting it. All right, let me erase what I had drawn, and let's see that this is indeed the graph. If I open up, here's, oops, I need to turn off annotations. Here's the actual function I graphed. This red graph is exactly what we have written over here, 3 cosine of 2x minus pi plus 1 on the outside. You might notice that I have also graphed 3 sine of 2x minus pi over 2, which is exactly the same graph, right? And so this is, if we had thought about this as a sine graph instead of a cosine graph, everything I just did would have been the same. The amplitude is the same, the midline is the same, the period is the same. The big difference will be the phase shift. So let's do this drawing again. If we're thinking of this as a sine graph, at its midline, sine is usually at 0. All right, not a great drawing, but, and so we had thought about, remember when we were doing cosine, we were thinking at 0, we're starting at the maximum and we need to move all the way over here. But if we're thinking of a sine graph, at 0, it's at its midline, it only needs to move this distance. which turns out to be a distance of pi over 4. And if we solve for c, we get pi over 2 instead of pi. And so we end up with the exact same picture with a different function involved, the sine with a different phase shift, which again reiterates that point I've made earlier that sine and cosine are the same shape, they're just shifted from each other. So depending on which one we choose, we'll have a different phase shift. And let's finally, let me get rid of this. All this stuff. Let's just put in that one with the negative amplitude. So I could put in -3 cosine of 2x plus 1. And that also lands there, right? So there's a third possibility, and there are an infinite number more, right? So just want to point out that there's not a unique function that fits these. There are possibilities, right? Sometimes, as I said, there'll be reasons why you would choose one or the other. Maybe you're relating it to something else and one turns out to be an easier relationship to see, so on and so forth. Or maybe whoever you're working with just asks for it in a certain form for consistency, right? If you're working with sines and you want to compare it to somebody else's sine graph, it's nice to be able to have a direct comparison instead of having to switch from cosines and so on. Or like I said, I like to keep my amplitudes positive. There's no really good reason for that. I just like it. I have a little phobia of negatives at the beginning of expressions that's completely irrational and not useful, but if I have a way to avoid having a negative at the beginning, I typically do. Okay, so that's it for this. Remember, we are just going in reverse. When we were finding, when we were graphing based on the function, we would do the same thing in reverse. We'd take A, B, C, and D, take their meanings and translate them to the graph, right? Draw your midline in. Where's your amplitude at? How big is a period? And then put in the phase shift, right? Here we're just doing that in reverse, looking at the graph to capture all these numbers. Okay, that's it for that one. Thanks, everybody. I will see you next time.